Hi, it's Miss Redican here. We're ready for our last part of our atomic story. We left off with Bohr's model, and Bohr's model made electrons seem predictable, right? They're like planets orbiting the sun, electrons orbiting the nucleus. You should know where they are. However, when scientists went into the lab, they tried to measure or locate an electron in an atom. Things were not so easy. So that brings us to Heisenberg, and he did use mathematics. And he discovered that mathematically, you can measure an electron's location, where it is, or its speed, its momentum. But you can't measure both. And this is weird. In the real world, if you throw a ball, you know where the ball is at every moment. You can see it, and you know its speed and momentum at every moment. You can calculate this beforehand, and you can verify it. But the electron doesn't use these rules for some reason, even though the ball is made of electrons, if you think about it. It's kind of weird. So, went to the lab and got more mathematics and came up with a model that we're going to take a look at here in the video. Okay, so I'm going to walk you through. We have our nucleus there. Look how tiny it is compared to the rest of the atom. And you have this electric field where electrons, and you can see they're unpredictable. And they have different shapes of where you can find them. Do they fill that entire space? No. Those spaces, those shapes that you're seeing right here are probability areas. The dark red shows you where the electrons are most likely to be with a certain energy. And you can see in the periodic table that as you add electrons, right, the shape changes, the probability of finding an electron in a certain area changes. And that goes back to Bohr's idea that every element had its own fingerprint, its own atomic spectra. So Heisenberg, along with these models from Schrodinger, took Bohr's idea to the next level, right? It improved upon it. It didn't destroy it, but it made it better. So let's go back and take a look at his model, at this last model, which is really Schrodinger, Heisenberg, de Broglie, a number of scientists. So let's compare. In the Bohr model, electrons are assigned to different energy shells, right? Fixed orbits. The quantum model, the electron cloud model, says we can't know exactly where an electron is at any given time, but we do know where they're more likely to be. And you saw that in the video, those red areas, those shapes. We call those shapes or areas orbitals, and they're areas of high probability. It's a little bit weird, but think of it like this. Let's say your parents call the school and they want to find you. And that secretary looks up and says, oh, you're in room 268 with Miss Redican. Okay. Well, there's a 90% chance you're there sitting at your desk. But you also could be in the bathroom, could be at the water fountain, could be at a lab table. There's only a certain amount of probability that you're exactly where you're supposed to be. So think of it that way, this idea that electrons, you know basically where that you should look for them, but they might not be there. And that's the electron cloud model. It's a little bit fuzzy, but it's the model we use today. Okay, good luck with the rest of your work.